What's the proper venue for appealing a question?
Something that you got points off on, or
Right.
okay, it depends on what it's on. If it's on homework, then that's your TA, Christina.
No, it's on the test, the midterm
Okay,
exam.
just send it to me.
Okay.
The details of what you missed and why you think you got it. I mean, I had 78 to grade, so I'm
I
sure
put
that
that
there
on,
were mistakes.
I put that on my
The reflection.
reflection, right.
Okay. Oh, that's fine. I'll take a look at it. I'm going to do those this weekend.
Very good. Thanks.
Hello, everybody.
It's
Yep, it is. It's the faithful few.
Hello.
How is everyone this week? Did you enjoy your sort of lighter week?
Absolutely.
Yes. Little bit of a respite. I know summer classes don't get fall or spring break, so I like to give you a sort of a break anyway.
Yeah, I personally appreciated it.
It's nice.
I really did. It was, and it was unexpected. I traveled. I'm in DC, but I traveled to Louisiana to see kind of sick parents, make sure, with COVID madness, everybody's okay. And I didn't know if I was going to be able to go. And I looked ahead and I said, wait, there's nothing due. Let me book this ticket.
Yeah, let me book this ticket. Yeah, no, it's sure. And it worked out pretty well for me as well. My brother lives in Columbia, South Carolina, which is about a 4-hour drive from where we are. And so his kids, who were supposed to have camp, didn't have camp, but they had this 2 weeks blocked off. And so they went to his house and isolated there, and they all got COVID tested, and then they came down here. And so they just left, 2 teenagers with my parents, to go back to take them back up halfway to Columbia. So it was nice for us as well. So the timing sort of worked out well all around. It was nice to see some other faces, So it was good. Okay, so we are moving on to chi-square tests. We can talk about that, or who has questions about whatever.
I have not done the homework. This is Marla. I have not done the homework yet, but there keeps being a thread on Biostat Buzz that people can't get into the discussion.
Okay.
And the thread is getting longer.
Okay. So, I was in the discussion yesterday. So discussions, let's see. One second. Guess I haven't checked those today. Which chi-square test would you do? I have one response on it. It should be.
Yeah, on Buzz, people are saying that they can get into the discussion, but for whatever reason, they can't see the questions. And God bless all these people who are able to do the work the day that the homework comes out. That's not me, but
so
I do follow
questions. I think the questions are in the notes. Let me go back here to overview of Module 9, Module 9 notes. Let me share my screen. That would be helpful. And let me see if those are downloaded. I'm on Module 9 notes. Getting people showing up today. Hello. Just 1 second to not be so angry at me. Oh, that's weird. Let's see. I thought they were here. Edit, find. Huh. That's weird. Well, then you guys are totally right. I wonder how somebody else got the right. Should ask that student where they found the instructions. Okay, I'll pop them up there.
I had a red colored marker box.
Okay. It's the same as all the other ones. Which test would you do? But I will, somebody needs to be muted. I will pop them up there today. So weird. Okay, I'll get them up. Other questions?
Thank you.
हल्की जो है हमारा जमाती दो बजे. But this is there till then. I'll find the ढक्कन for this. I'm okay with it. ये चल जाएगा. This is not even.
I am gonna go ahead and
कम होगा, but दो बार बनानी है.
I'm gonna mute her. Other questions? Be very short today.
Hello, I do have a question.
Sure.
On the test, I missed the question about the p-value, how we don't round it.
Mm-hmm.
And then this week I noticed in the notes that we rounded the p-value. What circumstances do we round the p-value?
So the p-value will be rounded. So in general, non-significant p-values, notice how I didn't say insignificant. Insignificant is a judgment, non-significant is a statistical decision. Right, so non-significant p-values are generally rounded to 2 decimal places. Generally rounded to 2 decimal places. Significant p-values are usually left at the 4 decimal place level, and then a journal will tell you. So when I write papers, I actually submit all 4 decimal places and let the journal tell me how they want the p-values, because different journals will have different decisions about that.
Okay, thank you.
Sure. Yeah, see, so here we've got a significant p-value. It's at 4 decimal places. And then that's at 4. No, they're all at 4. Wonder where. At any rate, that's generally the rule of thumb. When you are asked for an exact p-value, that's 4 decimal places. Other questions? It's okay if you don't.
I'd be happy for you to go over the chi-square test, the whole thing, because
Sure. I can do that. All right, let me pull up Microsoft Word here. Okay, so the basics of a chi-square test are a contingency table. The basics of it are always that you have 2 variables that are 2 categorical variables, right? So you've got, this is the lowest form or the smallest 2 by 2 table. And usually you have a predictor, or in epidemiology, it will be called exposure. And then you have an outcome. And basically you're going to classify everybody by what their predictor is and what their outcome is. What their predictor is and what their outcome is. So what's the X, what's the Y? What's the X, what's the Y? And you'll be able to divide them into these 2 by 2 tables. The beauty of frequency tables or contingency tables, particularly when you are reading other people's research, much like you had the Ethiopia proportions that you are dealing with, is that once you have these counts, if you can pull them out of a paper, you can recreate their statistical results. So that's much harder to do with continuous public data that are, or papers that are focused on continuous outcomes, because they usually just give you like a mean. But if you get the counts, then you can recreate their tables and you can do a lot with that. So if you're getting ready to prepare grants, if you're getting ready to submit and you need background research, as long as you can get counts from people's tables, you can actually do a lot of chi-square analyses because you don't need the individual data. And I'll show you that in a moment. So you'll want to arrange your table with your counts. And of course, JUMP does all this for you, but I want to sort of walk you through a little bit what the options are, because we'll deal with things like row percentages, which is out of this row, what percent were yes. So that would be A divided by A plus B. So out of this row, so of those on treatment A, what percent had an outcome? Or those with exposure, what percent had an outcome event? That's A over A plus B. What percent were no? That's B over A plus B. If you wanted to, what's called condition on the second option, so conditioning on this row, those are row percentages. So it would be C divided by C plus D. So that's where you get accustomed to saying out of or conditioned on those taking treatment B, X percent had the event or had the outcome. Those are row percentages. Column percentages are the same thing, just column wise. So out of those that had the positive outcome, or a yes outcome, or an event, or whatever your outcome yes is, what percentage were on treatment A? So you could also put this as male and female. You could say of those that had the outcome, what percent were male or female? That would be A divided by A plus C. So those are column percents. And we'll see in JUMP in a minute that JUMP gives those to you. Let me admit Judy here. Same thing with the column percents. You could say of those that did not have the outcome, or did not have the event, or did not have cancer, or did not have a heart attack, what percentage of those say were treatment A, or if that was female or male or black or white, just whatever category. So conditional percents are something that you talk about a lot when you're dealing with categorical data. And so that's conditioning on this row. What percent had yes, what percent had no. Conditioning on this row, what percent had yes, what percent had no. Conditioning on this column, what percent were A, what percent were B. Conditioning on this column, what percent were treatment A, what percent were treatment B. So those are conditional. They're called rows and column percents. Total percents are not utilized very often, but that would simply be the number of those that were on treatment A that had the outcome out of the total sample size. What percent of those were on treatment A that did not have the outcome out of the total sample size? That's a total percent. It's coming out of the total N. We don't usually utilize total percents a lot. They don't tend to make a lot of sense. And that's not really what we compare. What we're interested in comparing in a contingency table, open to my table here, is whether or not the proportion with the outcome is the same for those that took treatment A as it is for those that took treatment B. So the easiest way to think about that in the context of a clinical trial is if you are looking at, say, stroke. If our outcome is stroke, they had a stroke or they did not have a stroke. Treatment A is the standard treatment. Treatment B is the new treatment. Our null hypothesis is the same as our null hypothesis has always been. There's no difference. So before we were talking about how there was no difference in the mean value by group for a 2-group t-test. Now we're looking at, is there a difference in the proportion by the 2 groups? So instead of a mean, it's a proportion. And all we want to know is the proportion that were yes in treatment A different from the proportion yes in treatment B? You could compare the proportion no. Remember, these add up to 100% within row A. These add up to 100% within row B, out of those in A and out of those in B. So it's either compare the no's or compare the yeses. It's the same question. It's the same question. We usually compare the yeses. So that's our null and alternative hypothesis here. And it's the same null and alternative hypothesis that we've had all along. Null hypothesis, there's no difference between the 2 groups of our X by our X variable. The alternative is that there is a difference in the proportion with the outcome by our X variable. So before we had, is there a difference in the mean by our X variable? So the fit Y by X, and we were looking at means. Now we're doing fit Y by X, but we're going to be looking at proportions. So nearly everything has stayed the same. We are just now changing from means to proportions. So instead of saying we're looking at the mean weight, we would be looking at the proportion obese if you were doing it on BMI. Does that make sense? Just the slight shift in what we're talking about in terms of outcomes. So that's the table. And these are our hypotheses. Let me go into JUMP here. Okay, so this is our CombiRx infection subset. You guys have seen this data now. You're familiar with this data. I'm going to ask a very simple question here. Just a very, very simple question. Is there a difference in the proportion of people that have health insurance by gender? All right, so health insurance is yes, no, and gender is male, female.
Right.
Right? So if I pull up a new Word doc here, I can say, just a little bit bigger here. You guys can see that. That's my null hypothesis. Can also be written this way. Right? Females with health insurance is the same as males with health insurance. Right? So there's multiple ways to say they're the same. So is the proportion of females with health insurance the same as the proportion of males? Females with health insurance is the same as males with health insurance, or just more generally written in words, there's no association between gender and having health insurance. The alternative is the opposite. With health insurance. Oops. With health insurance. So those are our null hypotheses, null and alternative hypotheses. What we would report is the N in percent with health insurance for females, the N percent with health insurance for males. So that's where those conditional proportions come in. Let's go into JUMP here, and we're going to ask JUMP to do a fit Y by X. And gender is my predictor, because I'm not interested in predicting someone's gender if I know their health insurance status. Right? So gender is my predictor. Health insurance is going to be my outcome. And you can see here, our X is the red little histogram, and our Y is the little histogram. So we are going to get a contingency table. And it's called contingency table because you are contingent upon which group you're in. That's why they call it a contingency table, also called conditional. So press OK. And JUMP gives you everything you need. We don't really have to ask it for anything. In fact, there's not really like, we'll get to an odds ratio, but we don't have to ask it for the test. It gives us the test for a 2x2 table. Let's take a look at our friend here. What JUMP gives you is the counts, right? So I have 25 females that do not have health insurance. I have 220 females that do have health insurance. I have 14 males that do not have health insurance, and I have 85 females or males that do have health insurance. I have 245 females. I have 99 males. So I'm 71% female. I'm at 29% male out of 344. So those are my summary values. I would then want to report the percentage of females that have health insurance. That would be 220 divided by 245, except JUMP gives that to you in the row percentage, which is right here, 89.8. If you ever are confused, which people are, trust me, this takes a while to kind of get the hang of, pull a little calculator out and say, okay, I have 220 females, and I'm going to divide it by the total number of females. And that's 89.79. I can multiply that by 100 and get the percent. So 89.79 or 89.8% with health insurance. There's my proportion. That's my row proportion. Row proportions are saying within this row, what percent has each outcome? And those are right there. So you notice that adds up to 100. So of females, out of females, I've got 10.2% without health insurance and 89.8 with health insurance. I can do the same for males. Of males, I have 85.9% with health insurance. That's my 85 divided by my 99. And I have 14 people out of 99 that do not have health insurance, or 14.1% without health insurance. My question here is this proportion, 89.8, statistically not different from this proportion? Null hypothesis assumes that the percent of females with health insurance is the same as the percentage of males with health insurance. That's the null. This likelihood ratio p-value right here answers that question. Null says they're not different. Alternative says they're different. I have a p-value of 0.3061. Ron, what's my decision?
Your decision is the null hypothesis not rejected.
Yes, we fail to reject the null and conclude that while we observed a higher proportion of females to have health insurance, it is not statistically significantly different from the percentage of males with health insurance. Fail to reject. These are two-sided tests. With a chi-square, we are always asking proportion same versus proportion different. We're not into this one-sided greater than, less than in JUMP. It just gives you the two-sided. Now you can get the one-sided. If my question was, is the percentage of females greater than the percentage of males, I would divide this p-value in half. It's not going to be less than, because it's not less than. Right? We would never declare 89.8 less than 85.9.
What does the Pearson coefficient have to do with this?
So the Pearson chi-square is the original chi-square test. It was the first one that was developed. The likelihood ratio is a more sophisticated test, and it is more robust to departures from the assumptions. So if you have some smaller cells like we have here, the likelihood ratio does a better job.
Okay.
So I always report the likelihood ratio. I kind of wish they would get rid of the Pearson.
In column N, row female, just to give you numbers, what is the 7.27 and the 64.10? What do those numbers represent? I'm sorry.
Right, so JUMP will tell you right here, the first number in the cell is the count, 25. The second number in the cell is the total percent. So that's 25 divided by 344. The third number in the cell is the column percent, 64.1. That's out of this column.
Right.
So that's 25 divided by 39. That's the column percent. And the bottom one's the row percent. That is out of this row. That's 25 divided by 245. So you can always hide these. So you can get rid of the total and you can get rid of the column and just get the row percent.
Now you could have 2 by 2 is just kind of a generic term. That's I guess I'm not muted, is a kind of a generic old-timey term, but you can also have ratios, tables of 3 and 4, right?
Yeah, those would be called R by C or R by S columns. So rows by strata or row by column. So 2 by 2 is the basic. So this is akin to a 2-group t-test. Right? So we have 2 groups and we're comparing an outcome. That's a 2 by 2 table. 2 groups comparing an outcome. When we get into R by S tables, it would be like in ANOVA. You have multiple X groups and we're comparing the proportion across. So that is the basics of a contingency table. There's a couple of things that I wanted to show you all since you decided to join today. And what I was talking about before, when I said you have the data, if you can get data from a table, like from a table in a paper, they have counts, health insurance, yes, no, yes, no. If I was reading this paper and all they had was the table and they gave me the proportion with health insurance, but I also knew what the number was for males and females, I could complete the whole table. So you only have to know half the table with 2 by 2 tables. You can complete the whole table. So if I have the total ends, it's 245. I can pull out a calculator and go, okay, 245 minus, they said 220 people had health insurance. If I can type today. I always do arithmetic on a calculator. That means I have 25 females that don't have health insurance and I've got 220 that do. And so if I was just pulling this from a paper, you could even, if you can't get exact, you can get pretty close. So my yeses here, 85. And my no's here, 14. I can use jump and do a fit y by x. And I can make gender my x and health insurance status my y. And then if I tell jump that the N column, the count, is my frequency. Remember frequency analysis? Frequency means the count or how frequent something happened. If I tell jump that my counts are in this column, guys, look, it's exactly the same results. So you don't have to have row by row data to perform contingency analysis. All you need are the cell counts. All you need are these. All you need are these. So if you're reading a paper and they give you the N% yes, and you know the total, then you can complete the 2 by 2 table and you can run the analysis yourself. So that's the one thing that I really like about contingency analyses, because they might give you a table that has a lot of information in it and they might not report all the statistics for it because they're focused with something different. But if you're planning a research project, if you're planning to submit a grant and you need to know, hey, I wonder what percentage of people have health insurance in this disease area. Health insurance status might be reported, but it might not be the focus of the paper. You could still figure out what % of people have health insurance and whether or not it's different, even if the paper doesn't. So that's contingency analysis. Do you want to see one that is bigger?
Sure.
Okay.
Now,
So,
in our data brief that we're making, excuse me, our group, we have 5 different characteristics, but the outcome is a continuous outcome.
is it?
Yeah.
What's your outcome?
Number of visits to the diabetes care provider.
Okay. Is it really continuous or is it really skewed? Is it like most people have 0?
I don't know. I don't remember what it looks like.
So talk to your group about that. Talk to your team about that. If it's like most people have 0s and then there's a couple of people with 1 and 2 and then it's like goes 3 and then it's really sparse, you guys might want to categorize that into no visits versus any visits, or into no visits, 1 visit, or 2 or more visits. Just take a look at your data when you have it
And then that would become a contingency analysis.
Yes.
Right.
And that's why when you're planning data capture, if possible, capture the data as a number, because you can categorize it later.
Right.
But if they checked a box that said 0 visits, 1 or 2 visits, 3 more or more visits, you can't use it as a continuous value.
Do you care if the final grade or whatever, if it's a contingency versus a, okay, it doesn't really matter as long as we.
That is up to you guys. Look at it both ways and see what makes sense to your team.
Okay.
Okay, let's take a look at a 3x2. Unless, does anybody have any other questions on a 2x2?
I have a question
Okay.
about question 7 and question 8 of the learning quiz. So the question 7, the question I had was like, you have a p-value and n and percentage, right?
Mm-hmm.
So do we have to do like, for example, desirable, non-desirable categories, and then do age, gender, gender, education, race, ethnicity, and income? Is there a way we can do all these variables in one, and on the other axis we can put another one, or do we have to do each separately?
That's a great question. Let's just check here for you, Sipu. Let's see. Okay, so here's our CompuRx infection data set. Fit Y by X. So let's say I want to look at gender and race by health insurance and this diagnosis group category in the infection data set. So fit Y by X, and I put 2 predictors and 2 outcomes. Ah, look at, I got 4 results.
Cool.
Yeah, it's super fun.
Nice.
It works that way for t-tests as well in the fit Y by X if you had multiple categoricals that you wanted to look at. So yeah, and jump is really nice. You can just run them all at one time. And what it'll do is it will tell you, I mean, obviously you can tell from the table, but it will tell you up here, like which variables: health insurance by race, health insurance by gender, diagnosis group by gender, diagnosis group by race. So it will tell you which one it is. And when I do this, I'm actually fixing to do some later. When I do large things like this, when I have gotten the information I need out of it, I actually click the gray arrow and it will close it, so that I know that I've already like done that one. And then I can like look at this one and I can close it so that I don't get confused. But that's just a little jumpism. These little gray arrows will open and close things. Test in order to hide the contingency table. Also, one of the things that's really helpful for you all that I'll show you very quickly is that if I remove the total percents and the column percents, right, and I want to use this, if I use my big fat plus sign here, I can copy this and I can go to a Word document and I can paste it, and it brings your table in, and you can edit it from here. So that's super helpful. It just brings you in a 2x2 table. So you could then edit your ends and percents the way that you wanted them to look. So that's the big fat plus sign and jump. That's this one, big fat plus sign. And it'll copy any table, any chunk of thing that you want. Okay, so let's go back into our CombiRx data set here. And now let's look at race by health insurance. So fit Y by X, race, and health insurance. So this is a 3x2 table. 3x2 table. We're going to ignore this for a second. And we're going to look here and say, okay, African Americans, we only had 19 African Americans. We have 7 others. I can take it down to my row percents. And my question would be, is the percentage with health insurance different by race? What is something that you notice about this table?
it's more likely when we do chi-square, like, we have two dichotomous on one axis, and then we have the like trivariate on the other axis. Is that what I can see?
There's
So
also huge diversion a huge disparity between those answering and not answering.
yeah, so the first thing is that we do have 3 categories in our X variable, and that's totally fine. And we have 2 still in our Y, and that's fine. So that's okay. It's just a bigger table. And then what Ron said is that we've got this sort of disparate numbers. We've got the majority of the participants in this particular subset, because it's relapsing remitting MS, are white. So we have a little bit of an issue here. We've got a 0 cell. Got a 0 cell. That will make chi-square analysis sometimes really problematic. And if I look at my test, looky-loo here, what Jump has told me. Warning. 20% of your cells, these are my cells, I have 6 cells, 20% of them have an expected value less than 5. Expected value means that if there was no difference, if our overall percent of health insurance, which is 88.6%, so if each of my categories were 88.6%, what would I expect, what would my numbers be expected here? That's your expected cell size. You don't really need to worry about that, because Jump and SAS, and I don't know if R does, they give you a warning. They tell you that your large sample test here, this likelihood ratio, and for sure the Pearson, are suspect. Oh no, what do I do? The easiest thing, and what I would recommend in this situation, is to recode. This is why we teach you recoding, so that you look at white versus other. So I'm going to combine African American and others into a single category. So I can go back into race, columns, and do my recode. I'm going to call this race Caucasian other. And I'm just going to make this then other. So white, non-white. And that's just the, do a formula here. That's just the nature of this particular disease type. Relapsing remitting MS is a largely female, white, Northern European disease. That's just the nature of this particular data set. And so now I can go back and do my fit Y by X, and I can do race by health insurance. And I got to use the right race variable. I need to use my race other and health insurance. And now I can see that I've got 2 rows, and this is a fun example. I no longer have that warning, right? I no longer have that warning. What do you notice here, Ron?
Well, I mean, it's according to what we've learned is the statistically insignificant difference.
Yes, non-significant difference.
Right, oh yeah, okay.
Yeah. So Pearson's is saying this is not statistically significantly different, or likelihood ratio is. Pearson says it is. Oh. Well, as a physician, I want to publish my paper, so I'm going to pick the Pearson likelihood test, right?
Right.
Yeah, don't do that. People are going to, so this is where this is tricky. If you were doing a publication, you guys are getting a walk around publication world here. If you were in a publication and a statistician was reviewing your paper, as all good journals should have statisticians review papers, and you reported Pearson's and you reported these numbers, I would be like, I'm going to run that myself. And I would just determine that you picked the test that you liked because it was statistically significantly different. And then I would say, yeah, but now you're making your whole judgment based on 26 people out of 20. So the p-value doesn't tell the whole story. Now, I'm going to go ahead and say this is some strong evidence that non-white people with MS are less likely to have health insurance. But we did not see a strong statistically significant difference. Both the likelihood ratio and the Fisher's exact test, which is what you do for small samples, are saying no. Pearson is not a good test when you have small cell sizes. That's why it's giving you a weird result. But this is where your decision-making acumen comes in, where you can't just go, oh, I'm going to declare them different and write a whole paper on it. Because somebody is going to say you're declaring this giant difference based on 20 people. And I would never make a treatment decision based on 20 people, you know?
So for our purposes, the likelihood ratio is the one we should go by, right?
Yep, likelihood ratio is the one you should go by.
Okay.
I need to make sure that the learning check reflects that. I'll have to go in and double check that. So that's your option here for the race in this situation. The other option is you could have run the Fisher's exact on the 3x2 table, but it would tell you the same thing, that there was no statistical difference in that. So that's the 3x2. Let me see what else. Anything else?
And for the p-value in the question 7, right? Like, do we put the chi-square and p-value both in the question 7?
I'm not going to answer that for you.
All right. Okay. And number 8, what was my question for number 8? I forgot now. Okay. I'll come back.
Question number 8 is like, think about which analysis you thought was the easiest to write about for you and why. Do you think it's easier to talk about means, or do you think it's easier to talk about proportions, and why? That's a question for you. There's no right answer here.
No. Yeah, my bad. It was question 6 and 7. I was discussing the table and the other one. But I got my answer, because with the table, I wasn't sure whether I can do multivariable, but now you showed me. Yep. So that's done. And question 7, I've already recoded and done it. So kind of, but I'll include my p-values and things like that. No, thank you so much. I think I should be good on this. Thank you.
Sure. Anything else? I'm happy to sit down. We took a very long bike ride this morning with my niece and nephew. Any other questions today? I'm going to try to I'll get the discussion board 9. I'm fascinated how that other student found the questions. I'll get those questions up there. And then I'm going to go through the reflections this weekend on the midterms.
I do have a question about the team project. My team just wants to make sure that we're on the right track. So far, we've just been doing we've had a meeting almost every week. And then we've also gone through all the assignments so far. Mm-hmm. We want to make sure that we're not behind, or we're not supposed to be working ahead.
Nope. So after this week, you all will have all the information that you need to complete your data brief.
Okay.
Right? Chi-square is the last piece of the puzzle that most of you were probably waiting for, because most of the analyses you present will be that. So you can start. You've turned in your introductory paragraphs. You all had to write one. You can merge those into one introductory paragraph. You've got several examples of data briefs. Pick 3, 4, 5 fit Y by X questions in your data, whatever you specified in your prior hypotheses, and go to town. Do your jump, write it up.
Okay.
There will be, I think the date's already listed there. The full draft of the data brief. Let me see. Get here. Shouldn't be the full data brief. This is the bivariate analysis. So the question was the full thing. No, this is the bivariate analysis. So your fit Y by X's. So your fit Y by X's. When you run your fit Y by X's for your data brief, I want to see what those are. You don't have to write them, you don't have to have the introduction. Just turn in the analyses you intend to present using the guidelines and checklists. So you don't have to have the intro. You don't have to have the highlight points. You don't have to have the graphs done. I just want to see your fit Y by X's and what your conclusions are. And again, it's a draft.
That's for, what date is that?
It's due on Monday.
Okay, all right, I got you.
And so for your team dynamics, I mean, one person can do them. Or you can assign 3, if you've got 3 questions or 4 questions, you can assign Ron this question and Candace can take this question and Marla can take this question. We put them all in a Google Doc and turn it in. But I want to see the fit Y by X's for your data. And that can be a lot of cut and paste from jump.
Right.
Okay. And then for the due dates, I know it said August 7th, I believe. Mm-hmm. We have the final draft due. Yep. And then below it in the syllabus, it says final due. Does it mean final review or the actual final?
That's a super great question. Take a look here. I think it's the absolute final, but don't let me. So the final data brief is due that Friday, August 3rd, or data brief is due August 7th. The data brief is due August 7th. You have a final quiz. That doesn't work. It's a quiz. There's no, it's not like the midterm. So your data brief is the largest part of your final. There is a last, I think, 20 question, about the whole semester that will also be due, and I can make it due the following week. And then during exam week, you guys are just going to have the opportunity to look at each team's data brief and make comments on them. So you just get to see what all the other teams did.
So the final quiz is not like the final test. Tell me, I'm not sure I understand what you're saying.
The final exam is actually just a quiz. I think it's 20 questions. And they're all multiple choice.
What date is that?
It says final is due August 7th.
Okay.
That should say final exam week. I should have taken that off. I'll reiterate that. And it's a quiz. It's not really an exam.
Is it over the whole course's material, or just over the
questions like important things that you should remember?
Okay.
Sort of if I said to you a year from now, what do you remember from this class? It's not going to be analysis specifics. It's going to be conceptual.
I remember the tea dance. I remember that's what I remember. That's the most important.
This is a really important thing to remember because you're never going to forget the 2-group tea test. Anything else?
Just to clarify, so the figures and everything, that's due the following week, right? So
yeah,
we don't need figures
are
for
due
the 20th?
next week.
Okay.
Yeah, figures are due the next week. So this is all the points. And again, as far as your team goes, if you have one person that's really good at making figures, that person can make all of your figures. But the whole team needs to make the decision about what the figures look like. So if Shree's really good with Excel, she can take the things and say, okay, I've made all the bar charts, but then Ron might say, you know what, I think those should be a different color, or maybe we don't show the yes and no, maybe we just show the no's, or, whatever. So it should be a conversation amongst your team about what you're turning in, but it's totally, totally fine if one person makes all the graphs. Each of you has to make a graph. That's for the next assignment due a week from Monday. Everybody's got to attempt a graph, but for your final data brief, it can be one person. It just needs to be a team conversation about what they look like.
So the August 7th is still the last, is a draft.
No, August 7th is your final data brief.
Final data brief, okay.
August 7th is your final data brief. If you get me, and I think that might be on there, you can send me or submit to me something that week, and I can give you comments back. Let me see if it comes in here. I've got it listed.
So August 7th, we're done with everything.
Yeah, August 7th, you're done with everything. If final exam week, there's a post-course survey that you take. like the team survey, the one that you took at the beginning, you're going to take it again to see if your opinions on stuff have changed. And then you get to see everybody else's data briefs during finals week. And then also, just for full disclosure, we are in module 9 now. We're learning, you just had learning check 9, learning check 10, and learning check 11 are what you have left. Learning check 12 is optional.
So just to be clear on the bivariate analysis, so you're saying we can just run the fit y by x and then make a copy of it and paste it and then write up our conclusion on it and just do it like that?
So you can, the rubric's posted. Okay. So do you have an interpretation of what it was? Do you have an adequate number of findings, right? So I gave you you can't just put in one bivariate analysis. That's not enough.
Right. No, I mean for each one. For each one, like.
Yeah. Are things titled? And by graphs here, I don't mean like your final Excel graphs. Like if you do you have titles on stuff? Can I clearly see that this is health insurance by race?
Gotcha.
Percentages or means? I need to see those.
Okay.
Is there a significant difference noted? And then the source of your data has to be noted. So the rubric is there. You all can see it. This is worth 10 points.
Okay.
This is not worth 500 points. It's worth 10 points, and it's to make sure that you guys have done the bivariate analysis so that the next 2 weeks you can be cleaning up your data brief.
Okay. Thank you.
Sure. Other questions?
You're going to post this, aren't you?
Yep.
Okay. Very good. Thank you very much.
Absolutely. Everybody, have a good afternoon. Stay safe.
Thank you.
Yes.
Thank you.
Sure.
Thank you.